Hi everybody, I'm Carl Graffor. This year I've assisted the Arizona Department of Education with the design of Arizona's new computer science standards. And now we're creating these webinars to help teachers quickly get up to speed on the basics of computer science, those new standards, and hopefully help you implement them in your own classrooms. This is our webinar series 2, Essential Concepts. There will be 5 sections in this series with 1 video per section. The section we're discussing today is Algorithms and Programming. There will be a total of 3 different webinar series. Series 1 discussed what is computer science. This series, Series 2, discusses the 5 essential concepts of the computer science standards. And Series 3, which discusses the integration of computer science into other disciplines. Each series of webinars will have between 3 and 5 short videos. So where are these standards? Well, the approved Arizona computer science standards are available for download at the address shown on the screen. On the same page, there's also a download link for those standards broken out by essential concept instead of by grade to more easily show grade progression. Today's takeaway. The essential concept of algorithms and programming covers standards about algorithms, variables, control, modularity, and program development. So what are these essential concepts? Well, they're categories that represent major content areas in the field of computer science. They represent specific areas of disciplinary importance rather than abstract general ideas. Each essential concept is supported by various subconcepts that represent specific ideas within that concept. The figure on screen provides a visual representation. Each essential concept is color-coded to differentiate it from the next one. The color scheme is the same as shown on the slide, meaning that in all grades, the essential concept of algorithms and programming will be in blue. Algorithms and programming involves the use of algorithms. An algorithm is a sequence of steps designed to accomplish a specific task. Algorithms are translated into programs, or code, to provide instructions for computing devices. Algorithms and programming control all computing systems, empowering people to communicate with the world in new ways and solve compelling problems. This shows the progression of the task program development from 2nd grade through 5th grade and into 8th grade. In 2nd grade, students will map out a sequence of events to get to an end product. They will build a series of instructions or tasks. An example could be listing the steps to tie shoes or even make a snack. In 5th grade, students will further refine this process by outlining not only events, but constraints to those events, such as how to make a sandwich or a snack without bread. In 8th grade, students will seek diverse input from others to further refine their computational artifacts. If you look along the bottom at the practices, you'll also note that the practices change as tasks differentiate and become more difficult in increasing grade levels. The tasks, or I should say, the practices, may need to change in order to further reflect what those are. Lesson inclusion. How can you accomplish this in your classroom? Well, the top URL, it's a monograph published by Donald Knuth, one of the more acclaimed assembly low-level programmers of the late 20th century. He does an excellent job of outlining the differences between algorithms, programming, and coding. Basically, the differences are that algorithms represent your individual response to problems. Programming is applying logic and solving that problem with a program. Coding translates your program into a computer understandable language, or into a language understandable, by computers. The table shows some possible ways to include this subject in your classrooms. They don't necessarily need to be computer science classrooms. This subject matter transfers equally well into other subjects, i.e., language arts and social studies specifically. In 2nd grade, Students could use an automation program to create a visual guide or organizer. Students in this age group sometimes interact better with programs that have less options. The apps Shadow Puppet EDU and Buncee, both available for both Android and iOS, offer significantly less options, sometimes making it easier for students this young to cope. In fifth grade, students create an app or a program. They poll other students and adults to ensure they get a well-rounded view, and the app is actually written in pseudocode. Pseudocode is a natural language representation of computer code, making it more easily understandable by people. Eighth grade. Eighth grade provides the same concept as fifth grade, only in this case, students create a specific program that meets the need of someone besides themselves. This could be a person with a handicap, or even for an organization that assists others, possibly people with handicaps. It should still be coded in pseudocode, at least to begin with. It could be programmed afterwards using simple app creators like MIT App Inventor for Android or the Swift programming language for iOS. Those apps could then be uploaded to students' phones or devices, or even run on classroom PCs using emulators. Something like BlueStacks is an Android emulator. Today's takeaway. The essential concept of algorithms and programming covers standards about algorithms, variables, control, modularity, and program development. Algorithms are simply a list of stepwise tasks. Folks, thank you for your time.